Alright, so trigonometry has to do with the relationship between the angles of a triangle and the ratios of the sides. So, for example, I've got the main six trigonometric functions here: sine, cosine, tangent, cosecant, secant, and cotangent. And if I've got an angle, let's call it theta degrees. We don't know what the measurement is. Doesn't matter in this case. Um, by the way, in algebra, when you talk about unknowns, you usually talk about x. That's just kind of the default. In trigonometry or geometry, when you're talking about an unknown angle, it's common to call it theta, this Greek letter. So relative to this angle theta, the opposite side would be this one. I kind of think of it as you shoot across to the side there. So that's the opposite. Then the hypotenuse is just the hypotenuse. So if it's a right triangle, so the hypotenuse is the side opposite the 90-degree angle. So that's the hypotenuse. And then the side that's not the opposite side or the hypotenuse is called the adjacent, it, meaning it's next to um, the angle, but it's not the hypotenuse. Okay, so if I wanted to take the sine of theta, it would be the ratio of the length of the opposite side over the length of the adjacent side. Cosine is the adjacent over the opposite. Tangent is opposite. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Alright, and then cosecant is the reciprocal of sine. So if you find the sine, the opposite over hypotenuse, 1 over that is the cosecant. Basically just flip it over. Secant is a reciprocal of cosine. Cotangent is a reciprocal of tangent. So all that sounds like just a bunch of words, but let me just show you what that would mean in an actual situation. So I've got a 3, 4, 5 right triangle here, and I've got this angle here. Doesn't matter what the in this case, we're not going to focus on what the degree measurement is. We'll just continue to call it theta. So let's find out the values of the 6 trig functions for this angle. We could do this angle, and they would be different. We're going to focus on this angle. All right. So sine of theta would be the opposite over the hypotenuse. So let's figure out what the opposite would be. So this 4 is the opposite side, hypotenuse is 5, and then 3 is the adjacent. So the sine of theta is the ratio of the opposite over the hypotenuse, so it's 4 over 5. So you can leave it as that, or you can make that into a decimal, 0.8. Either way. So cosine of theta, these are just the normal abbreviations. You see those on your calculator. The cosine is the adjacent side over the hypotenuse. So adjacent is 3. And the hypotenuse is still 5. And then the tangent of theta is the opposite over the adjacent. So opposite is 4, adjacent is 3. Alright, now cosecant is the just reciprocal of sine. So just flip it over. So if sine is 4 over 5, then the cosecant is 5 over 4. Secant is the reciprocal, so I should say cosecant of theta. The secant of theta would be 5 thirds, which is the reciprocal of 3/5. And then the cotangent of theta would be 3/4. All right. So you might have heard of SOH-CAH-TOA. This is a little mnemonic device to remind you that sine, the S, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. Then just remember that cosecant is the reciprocal of sine, secant is reciprocal of cosine, and cotangent is reciprocal of tangent. So now we've worked out the values of the 6 trigonometric functions of this angle theta. Now, you know, if the triangle were like this, let's say, and we wanted the 6 trig values of this angle, they'd be different, right? This would be a different angle, and these side lengths would be different, so there'd be different ratios. So it's the sine functions are really the ratios of different sides relative to that angle. But the neat thing is, these are all for right triangles, and for example, we've got a 3, 4, 5 triangle here. If I were to create a similar triangle that's 6, 8, 10, and then the trig values of that corresponding angle would all be the same, right? Because they're similar triangles. Anyway, so there's your intro to the 6 trig functions and for right triangles and how to find them, how to write them, and there you go.